that we are looking forward to on cloud orchestration for the hybrid cloud architecture. So over to you, please, Greg.
Okay, thank you there, Simon. I took on the task of analyzing an existing hybrid cloud architecture in order to integrate the Azure and AWS cloud architecture utilizing lead standards. During this analysis, I found the following gaps existed on Azure and ASW integration. First of all, I found that Azure and AWS built their capabilities independently, so each have implementation and design differences. The resources that provide platform capabilities on one architecture are often organizing differently. Okay? A one-to-one relationship between services required to build a solution are not always clear. I also found that a particular service might be offered on one platform, but not offered on the other platform. And finally, Azure products and services are not available in all regions. The approach I took to arrive at a solution was, first of all, I aligned the lead objects to the Azure reference model. I then used a cloud decomposition map to create a matrix in order to identify the relevant objects to those entities. And thirdly, I created a composition matrix where I brought the objects together to show the lead meta objects allocated to the Azure and the AWS models. I then developed a cloud orchestration model using those composition matrices. I specifically focused on the long credit risk with SQL Server architecture and aligned the relevant lead meta objects with that. First of all, the relational IDE on deployed virtual machine, I aligned that with application services because what that deployed virtual machine integrated development environment does is a relational data statistical computing and sends the solution to the data service virtual machine. So basically, it writes scripts on that data and it sends that data to the virtual machine, the SQL server on that virtual machine. So I aligned that IDE with application services. And then the data service machine I align with platform services because that's a customized virtual machine image on the Azure cloud platform specifically used for data science analytics. And finally, I align the virtual Power BI, which actually takes that data and show a visual representation of the scoring of that data so the businesses, the banking can make a decision on which loans to actually grant. And I align that with data component. I then used the cloud decomposition map to break down the cloud components into groups and levels. This assisted me in creating the orchestration composition matrix showing the lead meta objects that were allocated to the Azure model. Now, by using that composition map, I was able to take that composition map and go into Enterprise Plus, the proprietary platform of lead, and I was able to identify and show the lead meta objects that were allocated to the Azure model. I then went through that same analytical process with the AWS cloud architecture, and I used the decomposition map to break down the components. Then I brought them back together and aligned them with the appropriate lead meta object. And I was able to create that model using the eEnterprise Plus and build those lead objects in Enterprise Plus. And by using the AWS Cloud Orchestration Composition Matrix, I was able to replicate the models with the appropriate lead objects. And here I'm showing a hybrid model, and I can show how the AWS and the Azure entities and architectures is aligned together. And that was done by using eEnterprise. Here, I'm just giving a higher view of the contextual view by replicating the lead objects from the class type perspective. And finally, I'm just showing a visual representation by using eEnterprise, how the Azure architecture and AWS architecture aligns. Okay. Now, by utilizing enterprise and industry standards and frameworks built upon the existing frameworks and concepts, I was able to visually display the integration of AWS and Azure architectures on the Azure reference model by utilizing the proprietary application, Enterprise Plus, which allowed me to build the lead objects and map them to and replicate them on the Azure reference model, thus mitigating gaps that were identified earlier in the presentation, resulting in reduced complexity, reduction in costs, and increased performance. And this is a conclusion of my presentation.
Okay, thank you very much, Greg. That was most informative and most lucid. Thank you.